Welcome to another video on digital electronics. In this video we will be seeing what is registers. So register is composed of group of flip-flops which is used to store group of bits. So as I always say, flip-flop saves one bit of information, be it 1 or be it 0. So if I have to save multiple bits of information, which means something like this, then this is called as a register. And to make this register we require number of flip-flops. So for storing n bit word, the number of flip-flop required is n. So how much ever long number of bit you have to save, that much number of flip-flops you will require. So one flip-flop for every single bit that we store. Now we come to the classification of registers. These registers are classified as serial in, serial out. This depends on the way the input is given and the way the output is taken, and hence they are called as shift registers. So the input basically shifts towards the output, and there are multiple ways to shift that output. So first one is serial in, the data will go serially in and the data will come serially out. Second is data will go serially in but it will come parallelly out. Then we have parallelly in data and serial out. Then we have parallel in and parallel out. So these are the four basic combinations. Apart from this, we have bidirectional shift registers and universal shift registers. So now we move on to the first category, which is serial in, serial out. So the flip-flop that we are using here is D flip-flop. The reason being, the truth table of D says if the current input is 0, then at the next clock pulse, my flip-flop will show output as 0. If the current input is 1, in the next clock pulse, the flip-flop will show output as 1, which means this is a delay flip-flop which shows the same input at the output in after one clock pulse. So say for example, I have to send or I have to store 1, 1, 1, 1 in a register. Then how many bits are these? These are 4 bits. And that is why we are using 4 flip-flop. Flip-flop 0, flip-flop 1, flip-flop 2 and flip-flop 3. So all of them will say 1, 1, 1 and 1. But how do we send this data? Since it is serial in, I have to send this 1 serially, 1 by 1. And serially I will get the data at the output 1 by 1. So first what we do is we send first bit D in as 1 here. So D3 will be 1 and hence Q3 will become 1 after the first clock pulse. Since initially everything is 0, after one clock pulse I will have 1 here and then everything is 0. Then I again put a 1 here, this 1 will shift, this 1 will shift here, this 0 will shift here and this 0 will shift here. So this will continue. To explain this in a better way, we have another truth table in which we have drawn all of this. So initial state is all the flip-flop values are 0. Q0, Q1, Q2, Q3. I have written D2, the reason being Q3 becomes your new D2, Q2 becomes your new D1 and so on. So initially everything is 0. After first clock pulse, this is one clock pulse. When my input is 1, since I have to save all ones, I am giving all ones here. Say your data is 1, 0, 1, 1, then you can give 1, 0, 1 and 1. There is no harm. Currently we are considering everything to be 1. So after the first clock pulse, I will have my D3 flip-flop as 1 and all other as 0, 0, 0. After the second clock pulse, I again have 1 at the input since I have to say 4 ones. So I have second 1. Now this 1 will get shifted here. My output for the first Q3 will be this 1. This 1 will get shifted here. The 0 will get shifted here. This 0 will get shifted here. So how many clock pulses it will take to serially send 4 bits of information? Of course 4 clock pulses, right? In the third clock pulse, again I have a 1 at the input, so I will have 1 here. This 1 will get shifted here, this 1 will get shifted here and this 1 will get shifted here. After the fourth clock pulse, I will have all 4 ones in my register. So this is how we enter the data serially. How do we get data serially out? I will have to send 4 zeros here. So first one will come out, then this one will come out, then this one will come out and finally this one will come. So this is how we do serial in, serial out. To make it much clear, we have waveforms also. So these are 4 clock pulses. First, the input is 0. At the first clock pulse, I make it 1. And since we are doing 4 1, so we make it 1 throughout. So this Q3 will turn 1 after 1 clock pulse. So this is the duration of 1 clock pulse. See, 1 positive and 1 negative. So after this will turn 1 for constant. After 1 clock pulse, this will turn 1, and after 1 clock pulse, this will turn 1. So eventually when you check, and after again 1 clock pulse, this will turn 1. So when you check your flip-flops, your Q3 is 1, Q2 is 1, Q1 is 1, and Q0 is 0. How many clock pulses did it take to get all of them 1? 1, 2, 3, 4. 4 clock pulses. So this is how waveforms are drawn. For example, if my data here, since we have all ones, I have given all ones. So say if your data is 1, 0, 1, 1, then you can give first 1, then 1, this will become 0, and this will become 1. So now this 0 will get shifted here. So there is no change as such except for the change in the data value. That's it. So I hope this is clear. Now we move on to the second one, that is serial in, parallel out. This serial input of the data remains the same except for parallel out. Parallel out means in serial out I used to get the data at the output one by one. But in parallel out I have 4 wires connected at the output. So at one clock pulse, at a single click of a clock pulse, I will get all my data parallelly out simultaneously. So this saves a lot of time when transmitting of the data is concerned from these kind of registers. Had this been serial out, it would have taken me 4 clock pulses to serially send data out. So first this will come out, then this will come out, then this will come out, then this will come out. But that is not the case here. So this is the structure of serial in, parallel out. Serial in concept remains the same. The data is sent serially at the input, but now it is taken parallelly from all the shift registers. And again you have your preset and clear connected and your clock pulses connected simultaneously. The third one is parallel in, serial out. This is also simple, but there is a bit of a logic that you have to apply. So there are these 2 lines drawn in orange, which is called as a shift or load. So they help to do 2 things. When this value is considered as 1, this NOT gate will make this as 0. So at this point it will do one of the operations, either shift or load, and when this is 0, this is 1, it will do the reverse of the operation. So let's see how this works. So these are my 4 flip-flops, because I want to say store 1, 1, 1 and 1. So it is 4-bit register. Parallel in means I will give my data parallelly in. So one data B0 will go here, then I have B1 coming here, then I have B2 coming here, and B3 coming here, right? So how do we give this data? For this data, I will have to make this orange line here 1, and before the NOT gate it will be 0. So see what happens when we do this. When this line is 1, we are doing AND operation with 1. So this is 1 connected here, right? Whatever I give here, 1, 0, 1 and 1 at B1, everything will go as it is through this AND gate to your OR. And since this line is 0, this AND will always be 0, right? Since this line is 0, this AND will always be 0. This AND will always be 0. So whatever I apply here, since this is 1, anything you AND with 1 is that number. If you do 1 and 1, it is 1. If you do 1 and 0, it is 0. So whatever number I have here will pass through this AND gate and will appear at this OR gate. OR gate has second input constant 0. Why? Because this line is 0, right? So this blue AND gate will always give me 0. So all this data will pass through this even number of AND gates and will get appear at this OR gate. and this OR gate will of course pass this data to the flip-flops. So this is how I am loading the data. This is what for loading the data. What you will do when you have to shift the data from this register to this register, to this to this to this. To shift this data, I will have to make this as 0 and I will have to make this as 1. So if I give 1 to this line, NOT gate will make this as 0. See what happens then. When we make this line as 0, anything that I load here will not appear here, because 0 into anything will make it 0. So all my even registers are 0. But my this line is 1 now. Because my this line is 1, these registers are active. These AND gates are active. So anything that is appearing at Q0, Q1 and Q2 will multiply with 1 and will appear at this OR gate. The second input is 0. Since this is 0, anything OR with 0 is that number. So it will appear, this will appear here and this will appear here. So see, this is how we shifted from this flip-flop to this flip-flop, from this to this and from this to this. So this is how shift operation happens. So by using this mode line, we are able to load and shift, and that is how we do parallel in. We are parallelly giving the data, and we are serial out. We are serially shifting the data outside. So this is how the concept of parallel in, serial out works. The last one is the most simplest one, which is parallel in, parallel out. So again, I will use the number of registers equal to the number of bits that I want to save. I will parallelly give the data in individually, and parallelly I will take the data out from each register. It is as simple. This is the most simplest register possible. So these were the 4 basic concepts of registers. I hope the concept is clear. I will stop the video here. Thank you.